Hello student, today I explain exercise 5.5 question number 5 y equal x plus 3 whole scale x plus 4 whole cube x plus 4 raised to power 4. First you take the log both side, taking log both side, log y, log x plus 3 whole scale x plus 4 whole cube x plus 4 raised to power 4. We have the log formula log m into n, log m plus log n, log y, log x plus 3 scale power we write down here, plus 3 log x plus 4, 3 power come forward right now, plus 4 log x plus 4. Here you apply to the formula log m n log n. This and power 4 we write down here. Now we do the differential with respect to x. Differential with respect to x, 1 upon y dy dx, log y formula 1 upon y and y chain rule dy dx. Now to log formula d upon dx, differential log x equal 1 upon x, and apply to the formula here. Then to 1 upon x plus 3, 3 into 1 x plus 4, 4 into 1 upon x plus 4, dy dx y 2 upon x plus 3, 3 upon x plus 4, 4 upon x plus 4. Now y value put it here, dy dx, y value x plus 3 whole scale x plus 4 whole cube x plus 4 raised to power 4. Then inside bracket there value 2 x plus 3 plus 3 x plus 4 4 x plus 4. We see the question number 6, y equal x plus 1 upon x raised to power x plus x raised to power x plus 1 upon x. First here you take let u equal x plus 1 upon x raised to power x, v equal x plus 1 upon x. Now y equal u plus v, differential with respect to x, then dy upon dx equal du upon dx, dv upon dx, number 1. Now we take the u equal x plus 1 upon x raised to power x, taking log both sides, taking log both side, log u x log x plus 1 upon x, x forward you write on the forward. Now you do the differential with respect to x, differential with respect to x, then 1 upon u du upon dx, and product will apply to it, x into log x plus 1 upon x, x plus 1 upon x into x differential 1, and 1 upon x we write on the x raised to power minus 1 into x minus 1, then log x plus 1 upon x, x difference we write down 1 only, Now du upon dx, u x into x plus 1 upon x, x downwards we take the LCM x square plus 1 into 1 minus 1 upon x square plus log x plus 1 upon x, bracket close, u x upon x square plus 1 upon x into 1 minus 1 upon x square plus log x plus 1 upon x into 1, and bracket close. Then you see here du upon dx, u is reciprocally do it here, x square plus 1, and you take the LCM x square minus 1 plus log x plus 1 upon x, bracket close, x square cancel, du upon dx, u value put it here, x plus 1 upon x raised to power x, x square minus 1, x square plus 1 log x plus 1 upon x, bracket close. Number 2. Now you see, take it there, v equal x plus 1 upon x. Now you take it, v equal x 1 plus 1 upon x, and you take the log side, log both side, log v 1 plus 1 upon x, log x. This is power I don't forward, apply the formula, log m raised to power n log n, apply to here formula. Now you see the difference with respect to x, then 1 upon v dv upon dx, and you apply to the product rule, 1 plus 1 upon x log x 1 upon x plus log x 1 differential 0 plus minus 1 here, x minus 1 minus 1 dv upon dx, v, and you take the LCM x plus 1 x 1 upon x plus log x minus 1 upon x square, bracket close, v value write down, x 1 plus 1 upon x plus 1 upon x square plus into minus, we write down minus log x upon x square, this one dv upon dx. Number 3. Now you know there dy upon dx equal du upon dx dv upon dx. This one du upon dx plus dv upon dx we write down. Therefore dy upon dx equal x plus 1 upon x raised to power x. This one x square minus 1 upon x square plus 1 plus log x plus 1 upon x, bracket close. Now dv upon dx value, this one I know, x 1 plus 1 upon x, bracket x plus 1 upon x square minus log x upon x square. Answer. Now you see the question number 7. Y equal log x raised to power x plus x raised to power log x. First we take here, let u equal log x raised to power x, v equal x log x. Now you see the y equal u plus v. Now differential with respect to x, dy upon dx equal du upon dx, dv upon dx. First equation. Now you take the u equal log x raised to power x. Taking log both sides. Taking log both side, log u log x power around here. Now do the differential with respect to x, 1 upon u du upon dx, and product rule apply to the x. Log x 1 upon log x, this one downwards, and log x 1 upon x is there, plus log x into 1. Now du upon dx, u this side around, the u value is there, log x raised to power x, bracket x and x cancel, 1 upon log x plus log x, bracket close. Now you take the v equal x log x, v equal x log x, taking log both sides, log v, log x forward diagram, and this one log x. Log x, log power is the forward diagram, here log x square. Now differential with respect to x, 1 upon v dv upon dx, 2 forward log x, 2 minus 1 into log x, 1 upon x is there, dv dx, v value x log x, 2 log x upon x, and we write down 2 log x log power x upon x. Number 3, this one number 2. Now we write down dy upon dx equal du upon dx, dv upon dx, dy upon dx, this one dv value log x upon x, 1 upon log x plus log x plus this one 2 log x log x upon x. Answer. Now you see the question number 8. Y equals sin x raised to power x plus sin inverse root x is there. First you take sin x equally raised to power x, then you sin inverse root x equal v. Let u equal sin x raised to power x, v equal sin inverse root x. Now you see there y equal u plus v. U equals sin x raised to power x, v equals sin inverse root x. Then y equal, this one you write on u, this one you write on v. Now differential with respect to x. dy upon dx, du upon dx, dv upon dx. Equation number 1. Now you take the u equals sin x raised to power x, taking log both sides, log u x log sin x. Power x forward diagram because log n raised to power n log n formula is there. Now log u equal x log sin x. Now you do the differential with respect to x. Differential with respect to x. Now we write on 1 upon u du upon dx. Here we do the product rule. X into log sin x, you write on 1 upon sin x, and sin x differential you write on cos x plus log sin x. X one is there. Now du upon dx equal u, meaning sin x raised to power x. This one shift to x, sin x is there. Now x into cos x upon sin x. Cos x upon sin x, you write down x cos upon sin cot x plus log sin x. Number 2. Now second one, we take it v equal sin inverse root x is there. Differential with respect to x, you do it there. Direct, not taking here, log x dv upon dx, sin differential is there, d upon dx, sin inverse x, 1 upon root 1 minus x square. Formula is there, apply to here. d dx sin inverse x equal 1 upon root 1 minus x square. Now we write down dv upon dx 1 upon root 1 minus root x square, and root x differentially do it there, 1 upon 2 x, 1 upon 2 minus 1. dv upon dx equal 1 upon root 1 minus root x square x, and here we write down 1 upon 2, here 1 upon 2, and x 1 upon 2 minus 1, x raised to power minus 1 by 2. Now dv upon dx equal 1 upon 2 root x root 1 minus x. Number 3. Now you see there dy upon dx equal du upon dx, dv upon dx. Now you see the du upon dx value, this one and this one you added there. dy upon dx equal du value sin x raised to power x, x cot x log sin x bracket close plus this one 1 upon 2 root x root 1 minus x. Answer.